All right, so we're going to talk about non-proportional linear relationships. In the first lesson, we saw the simplest type of linear relationship, one where the two variables are proportional to one another. In that case, remember that y over x equals k, or y equals k times x. The reason why you can get k times x is because you can multiply by x on both sides, and so it becomes y equals k times x. In other words, one variable is always a constant multiple of the other. So if x equals 0, then y is going to have to equal 0. So it's going to go through the origin. No matter what kind of number you put in for x, you're always going to have it go through the origin. So we'll always go through the point 0, 0. So consider the linear function f of x. The fact that it says linear means it's going to be a straight line. So you can even see the word line within the word linear. We're going to evaluate f of negative 2 and f of 1. What two coordinate points do these function values correspond to? Remember that since you're putting in for x, then your two coordinate points are already started. And now we're going to look at the graph over here. So f of negative 2, so where x is negative 2, y is negative 1. And when x is 1, y is 5. So if we were to calculate the average rate of change from x equals negative 2 to x equals 1, which is what we just found up above, we need to do the change in y over change in x. Well, the change in y goes from negative 1 to 5. Think about it as a number line. On a number line, you go from negative 1 to 5. You're moving to the right on a number line 6 places, so it's a positive 6. And then we do change in x from negative 2 to 1. Again, on a number line, you are moving to the right, so it's positive, and from negative 2 to 1 is 3. 6 divided by 3 is 2. This is also known as the slope of a line. Letter C is a different type of question, though. It's not talking about slope. It's talking about a proportional relationship. So y over x, is it the same? So let's look at the first coordinate point of negative 2, negative 1. So negative 1 over negative 2 is a proportional relationship of 1/2. And the other one, y over x, is 5 over 1, which is 5. Do these have a proportional relationship? No, they don't, because 5 and 1/2 are not the same. Letter D, based on your 8th grade coursework, what relationship does exist between the two variables? Well, y equals mx plus b. We already know that it's a linear function, so we can use the linear equation of y equals mx plus b. Remember that m is your slope and b is your y-intercept. So we need to find the slope of the line. Well, we found up above that the slope is 2. Now the y-intercept is where it crosses the y-axis. Where it crosses the y-axis is at 3. So if we were to put this into the equation, it's y equals 2x plus 3, because we plug the 2 in for the m and the 3 in for the b. In general, what is always proportional in a linear function is the change in y to the change in x, also known as the line slope. This gives rise to what is known as the slope-intercept form of a line, which is y equals mx plus b, or f of x equals mx plus b, where m is your slope and b is your y-intercept of the line. So given the linear function g of x equals 1/2 x plus 1, do the following. Create a limited table of values to help graph the function. So I have x and y. So 0, 2, 4, 6, 8. The reason why I went up by 2s is because it is divided by 2, so you can always take a half of each of these numbers. So if x is 0, half of 0 is 0, plus 1 is 1. Half of 2 is 1, plus 1 is 2. Half of 4 is 2, 2 plus 1 is 3. Half of 6 is 3, plus 1 is 4, and half of 8 is 4, plus 1 is 5. So create a graph of the function on the axis below. So when x is 0, y is 1. When x is 2, y is 2. When x is 4, y is 3. When x is 6, y is 4. What you will notice, and then we can always go backwards the same. What you'll notice is the slope is up 1 over 2, up 1 over 2, up 1 over 2, all the way across. So it is going up 1 over 2, which is the slope. And then the y-intercept is where it crosses the y-axis, which is 1. Use information about the slope and y-intercept to graph this on the grid. Pick 2 points off the graph and calculate the average rate of change and verify that it's equal to the slope. So, let's look at our y-intercept. That's always your starting point. So you're going to start at positive 4 on the y-axis. Then we have a slope of negative 3 over 5. So that means from our starting point, we go down 3 over 5. And we can go backwards to up 3, left 5. Remember, when you are doing the slope, you always run to the right, but if you work backwards, that's when you go to the left. So pick 2 points off the grid. I have 1 point here, 1 point here. The first point is negative 5, 7, and the other point is positive 5, 1. So, change in y over change in x. From 7 to 1 on a number line, you go to the left, which means you are subtracting. From 7 to 1 is negative 6. And then from negative 5 to 5, you're going right on the number line, so it's a positive number, and it is 10 places. Now we can reduce this number to make negative 3 over 5, which is the same as your slope.